Hi, everyone. To continue this solubility lesson, we're going to do a little activity that we used to call Solubility Theater. And Solubility Theater is an activity where you model how a solute and a solvent mix together to create a solution. And we are going to focus on creating what are called hydration shells around our ions as well as around our polar molecules and trying to model what happens when something solvates or actually becomes dissolved. So what I'm going to do is I'm going to read through the objective and the rules and then go through one example with you so that you know how to go through this activity. So the objective of this activity is to demonstrate ionic polar covalent and nonpolar covalent situations within a solution. The rules for building these models is that the negative side of the water is always going to be attracted to the positive cation, assuming there's a cation. The positive side of the water is going to be attracted to the negative anion. It takes two waters to pull an ion from a crystal. However, once that ion is removed, 4 waters are required to create the hydration shell or to solvate it, which means to dissolve it completely within the water, which is what makes it look like it disappears. And then only ions on the corners can be dissolved. Now, normally in the classroom, we would do this live using people as waters and as ions and as polar molecules and whatnot. But because you are at home, we're going to do this with just our drawn models. So for each of these scenarios, you're going to be using these images and you just simply click on them and you can copy and paste them wherever you need to. But these are all the molecules that you're going to have to work with. So just make sure that you pay attention to the orientation of them as you go through the actual activity. The example I'm going to do with you is going to be of sodium chloride. So let's go ahead and take a look at that. So what happens when an ionic compound goes into water? Well, you should have learned from a previous video that ionic compounds, most of them actually do go into water and dissolve completely. And when they do, they completely ionize, they come apart. And we can model that with what's called a dissolving equation. You'll have an opportunity to learn more about these equations at the end of this unit if you are interested. It's an extension. But sodium chloride solid goes into water and then comes apart as sodium plus cations and chloride anions. And they're in a 1-to-1 ratio because we're talking about NaCl, which happens to have a 1-to-1 ratio. So what I want to do is in this first box, I'm going to show a crystal of 2 formula units of NaCl. That means 2 NAs and 2 Cls. So I'm going to go back to this and I'm going to copy my Na. And I'm going to put 2 of them in here. Oops. Hang on. There it is. I'm going to move it over here. And I'll just put another one. And then I need a Cl, so I'm going to copy and paste that. And let's just, oops, could have sworn I copied the Cl. Let's try that again. Right. There it is. And I'm going to put another one of those in there. So as a crystal, you want to make sure that you're forming that lattice structure of positive to negative, negative to positive. So no 2 positives are next to each other and no 2 negatives are next to each other. But when they go into water, what will happen is these ions will come apart, like Mr. DeWitt said, and then we'll have our waters surrounding them. So all I'm going to do is I'm going to take this guy and I'm going to move it over to the other side. And I'm going to show you what that hydration shell should look like once you have it all dissolved correctly. And the way I do this is I go and I copy a water. And I want to make sure that the water is facing the correct direction. So the way that we make sure that it's facing the right direction is we're going to have to rotate it a little bit. but I'll use my cursor to show you which side is the negative side and which side is the positive side. The big red circle represents the oxygen, and then the white circles represent the hydrogen. So this is the negative side, this is the positive side. So we just want to make sure that our hydrogens are facing our chlorine, because that's the positive side of the water. And then I want to add a couple more of these. So I'm going to copy and paste a couple more. And I'll put one over here. And again, I'll take this little dot here in order to rotate it a little bit. And then I'll copy and paste another one of those. I have to rotate it as well. A little bit more. And then last but not least, since it takes 4 to completely dissolve, we need to put one more here. And there's my hydration shell around the Cl-. Now I just need to do one more for the sodium. Oops. We're going to put a sodium one in here. And I realized that in this box it said to show 2 formula units. But for this video, I'm just going to show one so that so that you don't have to watch me do another full set of these. But now I'm going to take waters and I'm going to put them around. But when I put the water around the sodium, I now don't want the positive side facing the sodium, because this side is positive, this is positive, they would repel. So instead, the water is going to take its negative side and face the sodium. Like that. All right, and now I need to take 4 of those. So I'm going to copy and paste it over here, and then rotate it around. And then I'll copy and paste that. And go around. Oops. And then copy and paste. And now I have drawn a full hydration shell around 2 ions, which is 1 formula unit. Technically, this says to do 2 formula units, but you get the idea. So the idea is that inside of the solution, these ions would separate, and they'd be separated because the water would come in and latch onto these ions and then pull them apart. And then after they're pulled apart, more water molecules will come and surround them. And that's what makes them look like they disappear within the water. So these are your hydration shells, all lined up based on their polarity, positive to negative. Okay, so now for the rest of the slides, you are going to be using the same models. You're going to be copying and pasting them and arranging them according to what the prompt asks you to do. All dissolving equation models are given at the bottom of each slide until you get to the very last slide. And then there will be an opportunity for you to watch a video and learn how to write out these equations and then practice those as well. Okay, thank you.